Next, we're going to find x and y intercepts. When finding x and y intercepts, we always use the reduced form of the rational function. Similar to any other function, when we are looking for x and y intercepts, we substitute 0 and solve. So to find the x-intercept, we substitute 0 for y and then solve for x. The answer is going to look like some value, comma, 0. Whatever the x you solve for will go in the x spot, comma, 0. But to find the y-intercept, we substitute 0 in for x and then solve for y. So the answer will look like 0, comma, some value. So let's try to use this to find some rational functions, x and y intercepts of rational functions. So the first thing is, it said we always have to use the reduced form. So if this can factor and cancel or reduce, then I would need to do that. So we have 3x and x, 2 and 1, c minus and plus, and that's going to get, okay, does the numerator divide out with anything in the denominator? No. So in this case, because it doesn't reduce at all, then either function is fine. You can use either one, and that's fine. So on the left hand, we're going to use left-hand box. We're going to try to find the x-intercept. Do the same on the right-hand box. To find the x-intercept, you substitute 0 in for y. Remember, f of x is kind of like y equals. So we have 0 equals 5x minus 2 over 3x squared minus x minus 2. Okay. Now, when you have 0 equals a fraction, often when you have a fraction equals a fraction, it's really easy to just cross multiply. So I am going to change this 0 to 0 over 1, because any whole number can be written as a fraction if you just put that whole number over 1. So I'm going to cross multiply. So I multiply 0 times the denominator, 3x squared minus x minus 2, and 0 times anything is 0, equals, so and it doesn't matter if you put it on the left or the right, but when you cross multiply, there's an equals between them. Sometimes people try to cross multiply and make another fraction. Well, that doesn't help. You're trying to get rid of the fraction. So when I cross multiply again, 1 times the numerator 5x minus 2 is just 5x minus 2. Now I can solve for x. So that gets me 2 equals 5x by moving the 2 over. Divide both sides by 5. I'm getting x equals 2/5. So my x-intercept is 2/5 for the x, comma, 0 for the y, because I'm the one that plugged in 0. Now, if you noticed here, if you're always going to be setting this equal to 0, 0 over 1, what happened here was on the next step when we cross multiplied, the 0 in the denominator zeroed out. So really all you had here was 0 equals your numerator. Now that's going to happen every single time. So if you don't want to set the whole function equal to 0, the shortcut would be just setting the numerator equal to 0. Because if the numerator is 0, then the whole thing is going to be equal to 0. So we're going to talk about that shortcut in just a moment. Let's go ahead and try the next one, the y-intercept. In order to find the y-intercept, I know my answer is going to look like 0, comma something. I'm just going to plug 0 in for every x. So f of x, but x is now 0, is 5 times 0 minus 2 over 3 times 0 squared minus 0 minus 2. So I'm working the top, and that gets me negative 2. I work the bottom, and that gets me 0 minus 0 is 0 minus 2 is negative 2, and that reduces to 1. So 0, comma 1. Again, if you don't want to think about it as plugging in 0 for x, you can always just think of this as find f of 0. Okay? Alright, so let's talk about some shortcuts. So the shortcuts for finding x and y intercepts are to find the x-intercept, as we talked about in the last question, you're going to set the numerator only equal to 0 and then solve for x. The answers again are going to look like some value, comma 0. To find the y-intercept, like we talked in the last example, the shortcut is just to find f of 0 and then it's going to be 0 comma some answer, and that's the way the y-intercepts will look. Now, as a reminder, all functions need to be in the reduced form, so I'm going to go ahead and factor those out. Now, there's nothing in the numerator or the denominator that divides out, and so and these are both the same. So you can use the factored form or the original form, it doesn't really matter. But let's try the X-intercept. The shortcut is to set the numerator equal to 0. Because I already factored it, I'm going to go ahead and use the factored form. Set the factored form equal to 0. So I have x plus 2 equals to 0, x minus 2 equal to 0. And I solve each one of those. A lot of you can probably do some of these steps in your head, and that's fine by me. I'm getting x is equal to negative 2, and x is equal to positive 2. So the x-intercepts are 2, 0, and negative 2, 0. Notice, because it's x-intercepts, you could have more than one, or you could have just one. You never really know. But notice on y-intercept, there's only ever one y-intercept. There's no plural there at all, because you're only going to ever have one if it's a function. So the shortcut to finding the y-intercept is just to find f of 0. So just plug in 0. I'm going to go ahead and use the original because I think that's a little bit easier. So I have 0 squared minus 4, which is negative 4 in the numerator. 0 squared plus 0 is 0 on the denominator. And negative 4 divided by 0 is undefined. Okay, so a lot of times people want to say that's 0. It's not. You're not allowed to divide by 0. So a 0 under the line is undefined, which tells you you are not going to have any y-intercepts. But notice we found it the same exact way. Plug f of 0 in, and it still is going to get you an answer even though this one happens not to have any. Most likely what you have is a asymptote, a vertical asymptote right there on the y-axis, which is why you don't have a y-intercept. Let's try these shortcuts one more time. For the x-intercept, we're going to set the numerator equal to 0, but before we do any of that, I want to factor to make sure I can't reduce anything. So on the numerator, factors into x plus 3x minus 1 over x minus 1, x plus 1. Ooh, something does divide out, the x plus 1 and the x plus 1, which means my reduced form is x plus 3 over x plus 1. So if I have, I'm going to go ahead and reduce that on this side too. I'm not going to show you the work because it's the same function, okay? So when I'm trying to do the x-intercept, I set the numerator, the reduced numerator equal to 0, and that's going to get me x equals negative 3. So my x-intercept is negative 3, 0. Again, if you reduce it, it's actually simpler, and because it's more simple, then it's easier to do. For the y-intercept shortcut, you just find f of 0. And again, I'm using the shortcut, so that's 0 plus 3 over 0 plus 1, and that gets me 3 over 1, or just 3. That's 0 for x, 3. Okay, and that concludes this lesson.